Hello, Mr. Betts here. Let's take a look at an example of how we might take a model, so a function that models a real life situation, and interpret different things about that model. So the first part here, we want to know, what does p of 20 mean in the context of this problem? So the function p just gives the population of deer in a particular area a certain number of years after the year 2000. So P of 20 is going to be 20 years after the year 2000, and it's just going to tell us the population. So whatever the value of this is, it's just going to be the number of deer that live in the forest in the year 2020. So we might be a little bit more specific and say on January 1st of 2020, because obviously population is not going to be the same during the whole year, but at maybe a certain point. So at t equals 20, that might be the very beginning of 2020. That's how many deer are in the forest. P prime of 20 is the derivative of the population. So remember, the population is measured as the number of deer, and t, our independent variable, is in time. So the units that we're going to have on the derivative are going to be the number of deer per year. And so what this is telling us is the instantaneous rate of change. So we could also say just how fast the population is changing. So of the deer population and that would be at the same time as part A. So when t equals 20, it's going to be year 2020. Let's say at the beginning of the year of 2020. So the important thing to keep in mind here is this is an instantaneous rate of change. It's not the rate of change over some interval. So it's just telling us how fast the population is changing at a particular instant. And I know I already wrote it over here, but we always want to include in our description the units. So we can say in deer per year. Part C, this one's pretty closely related to part A. So if we just said P of 21, that would be the number of deer at the beginning of the year 2021. The P of 19 is the number of deer at the beginning of the year 2019. So this would be, if we subtract them, we can assume with our answer that the answer is going to be positive, and if it's negative, we would interpret it the same way. So this is going to tell us how many more deer there are at the beginning of 2021 than 2019. So, for example, I'm just going to give some nice round numbers here. Let's say January 1st, 2021, there's 5,000 deer in the forest. January 1st, 2019, there are 4,000 deer. So if we subtract them, that 1,000 deer that we get is the population difference. So that's how many more deer there are. If this were a negative value, then if we say how many more deer is a negative number, then that would indicate that the population is going down. Part D, it includes that same value. So the change in the population over that time interval, but then we're dividing it. So this is the numerator here is going to be the increase in population over 2 years. And then we're going to divide it by 21 minus 19. So that 21 and 19 are actually representing t values. So we're dividing it by a 2-year interval. So the units that we're getting here are actually the same units that we had in part B, because the numerator is a number of deer and the denominator is a number of years. So the units are going to be deer per year, but this is not an instantaneous rate of change. It is a rate of change, but it's going to be an average rate of change. Okay, so it's going to be the average, I'm going to say increase. If this is negative, then it would be a decrease. So the average increase of the deer population in deer per year between beginning, and I'm saying the beginning here because I don't want to misinterpret here and say that it goes from 2019 to 2020 into 2021 and actually over a 3-year period. It's over a 2-year period. So the beginning of 2021, from the beginning of 2019 to the beginning of 2021. So we have the units here, deer per year. And so if we just throw some numbers out here again, I'll use the same numbers I used on top here. This is 1,000. So the population went from 4,000 to 5,000 over that period. Over the 2-year period, it's an average increase of 500 deer per year. Now, it could be the case that the population increased by 200 one year and 800 the next year, but the average increase, so the average rate of change, is going to be 500 deer per year. The last one here, the second derivative, is kind of the trickiest one, I think. So the second derivative is, let's think about units first here. So the first derivative has units deer per year. But if we take the derivative of that again, it's going to be deer per year per year. And so this deer per year is going to be the instantaneous rate of change, how fast the deer population is growing at any given time. And then if we look at how that's changing per year, this is how fast the rate of change of the deer population so how fast that rate of change is changing at the beginning of the year 2020. And then we should also include units in deer per year per year. So the first deer per year is how fast the population itself is changing. And then the second per year is telling us how fast that rate is changing. So it's the instantaneous rate of change of an instantaneous rate of change.